Hey there, hope you're having a good day. Today we are talking about the start combat / event begin play part of the JRPG Combat System. This is a classic turn-based combat system. It includes a full suite of functionality that allows you to focus on other aspects of your game. Excuse me. It is designed to be easily integrated into existing projects, providing you the flexibility to pursue your creative goals. In this series, I'm detailing the entire system, allowing you to learn the system, modify it, or even build it yourself. You can buy it, link in the description. Obviously, you are free to follow these guides and build it yourself. No purchase necessary. So let's get into it. So, event begin play. This is a little deceptive how simple it looks. A lot of it goes into this event under start combat. So we wait one frame for technical reasons, making sure everything in frame one is buttoned up before we get started. We rely on some of that information, so we just want to make sure there's no clash here. So we delay until next tick. Then we call this start combat event. Okay, we're going to set show mouse cursor to true because a lot of the things in the system require clicking on stuff, so we need that to be visible. Let's get into start combat. So this is in a separate event graph called the combat engine. You see start combat, start turn, next turn, end turn, unlock, end turn. And we're starting with start combat, the very beginning of the combat engine. A lot of what we do here is initiating other aspects of the engine to be used later. I'm not going to mention the diagnostics bookends past right now, but just so you know, almost everything I have a diagnostics function at the start and at the end, just to put something on the UI, you can turn it on and off inside of that function. I talked about it in a previous video. Okay, but it's all over the place here. That's the purpose. I'm not really going to talk about it every time I come across it, aside from right now. So diagnostics bookends all over the place. Then we have, here's where I'd recommend you remove any mapping contexts you have on your player controller that are letting you control the overworld, just so that your character isn't running around while you're in combat. That can be kind of goofy. Here's where I'd recommend you remove it. It's not connected, but this is where you would implement it here. Construct battlefield we talked about in a previous video. Not going to talk about it other than to say it's just here to make sure we got everything that we need from everything we needed, so everyone can join combat, which is the next function. Invite all combat actors. This cycles through a combat actors array, calls the join combat on that JRPGCS combat or the blueprint interface. Okay. Camera setup. This is where we get our different point of views set up for combat. So you'll notice that the driver has a center spring arm and a center cam already. Unreal has kind of a quirk, I guess you might call it. Multiple cameras on one actor doesn't really function in a usable way, at least not that I found. And so what this actually does is it creates some other actors we can use as cameras. Okay, so we have one actor, or we have one camera already on the driver. That's great. We need a few other camera angles. So this camera setup is going to create those. So the first thing it does is adjust the relative, based on the relative center of the battlefield, it adjusts the center spring arm so that main camera is in the right spot for us. Then we're going to spawn a couple of actors. All these actors are, I'm going to click browse and I'm going to open it up. You'll notice all this actor is a spring arm rotated at minus 35 degrees at a length of 900 with a camera on it. That's all it is. That's all we need it to be. Okay. It spawns that actor, sets the troop cam actor variable, and then it's going to spawn another one and set it as the party cam actor variable. And the math over here is all about getting the correct positioning for the camera based on the relative center of the troop And you'll notice it's the same down here except for the relative center of party. So we're rotating it by the driver, offsetting it by the driver world location, because again, these are separate actors, so they need to be world locations when you give them their positions. And then we are rotating it relative by -35 on the z-axis. That's to give us facing one direction, and then you'll notice the party cam is positive 35 degrees. Okay. The transforms of these is very important, but that's how you set them. And just to kind of show you, if I click play here and then press F to trigger combat, we'll see if it actually does it. It's set to randomly move the camera. You can obviously make it move them as you choose, and I'll show you how to do that later on when we get into camera. And it's not moving the camera. There we go. Okay, you saw how it moved the camera, right? I'm not crazy. Well, maybe I'm a little crazy. Anyway, so that camera movement right there is because it has the actor positions with those additional cameras that it references as it moves between those points of view. Okay, so that's the purpose of camera setup. Let's move on to speed. Speed in the JRPGCS is based on turn charges. And what a turn charge, it's a value of 0 to 1. If you're at 1 or above, you can act. If you're below 1, you are waiting until your turn. And it's always the person with the highest turn charge value that acts first. So if more than one person or actor is above 1, it takes the one with the greater value. So let's talk about this here. The average speed is a variable that's kept on the driver. All this is doing a local variable of average of all speed, which is an integer array of everyone's speed values. What we're doing is we're going through each combat actor, and we're getting their speed. If their speed is not equal to 0, we're adding it to that array, and then we're getting the average speed using the average of int array, which is an inbuilt function in Unreal Engine to get the average speed. Okay. Then we're initiating turn charges. All this does is create an array of floats, all equal to 0, that tie directly back to each combat actor. So we're going through our array of combat actors, and for each, we're setting the index of this combat actor's turn charge array to 0. So an index 0, that actor, has a corresponding index 0 in this array over here that represents their turn charge. Then we're increasing turn charge. This function is called frequently in the engine because this is like the engine's cycle. Each time it cycles, it's increasing everyone's turn charge by a value relative to their speed value. Okay, so in here for each combat actor, we're getting their speed, and we're getting whether they can act and are they alive. If both are true, they're going to gain turn charge. Okay, because if either is not true, their turn charge value is getting set to 0. And so if they can act and if they're alive, we are using this calculate new turn charge function, which I'll explain in a moment. We're getting their current turn charge and their speed. It's going to output a new turn charge, which is going to be set as their turn charge. How many times can I say turn charge? Let's talk about this function here, calculate new turn charge. You'll notice that these are the same. And what it's doing is, compared to the average speed, And I'll explain why they're the same here and why you might want them to be different, why these are different. But to explain what's going on here, based on the average speed, we're doing a comparison to the current actor's speed and increasing their turn charge by a certain amount. Someone has double speed, they're getting double the amount of turn charge. But everything needs to be relative. And so that's why there's some math going on here. And it's outputting that new turn charge that is based on the average speed, which we got earlier. The reason why these are different is there might be instances where you want your UI to maybe be a little more reactive and extreme than the actual technical speed value, just to draw attention to this person is a lot faster. So to do that, you would maybe make this a lower value here so that the average speed divisor here, so we're taking their speed and dividing it by the average speed times 10. If you make that smaller, the UI bar is going to fill up quicker, or it's going to appear to be full quicker than it actually is, just to show that, hey, this person is going very fast compared to others. So, but in this implementation, they're the same. You can play with that. Decide how you'd like to see it. Next, we are doing some UI stuff, and this will be the last thing that we're doing here. So the first thing we're going to do is show the HUD. We're going to update the turn order, and we're going to create some status bars, which are the little overhead bars. So let's talk about the HUD here, showing the HUD. And the HUD itself will need to be a separate video. It's just not possible to go over all of the HUD elements in this video. But what we're going to do first is we have a variable for the HUD that is assigned here. Only if it's not valid. If it's already valid, so we're checking if that variable is valid. If it is valid, we don't want to do anything because it already exists. If it's not valid, we're going to create that HUD. Okay, and we're going to set that variable. Then we're adding it to the viewport. And then we call this event dispatcher refresh UI. The refresh UI event dispatcher just tells all these different UI elements to update, because typically you don't want things happening every frame. You instead want to use event dispatchers, and anytime a UI element could or should be refreshed, we're calling this event dispatcher, so we don't have to worry about stuff being on every frame to collect data. It only collects it when it makes sense to collect it. And so we have this event dispatcher to do that. And so we're doing that after we've added, after we've shown the HUD, we're showing the HUD, adding it to the viewport, then we're refreshing the UI. Then we are updating turn order, which, okay. So we're getting the turn charges of all of our combat actors and caching that first. Then, if we go down to local variables, just so we have everything, we have our combat actors turn order. We're clearing some of these local variables because we've got their existing turn charge, but then we have what's going to be their turn charge next turn, which is important because you want to show where they're currently at, and then you want to also show where they are going to be. And so if I hit play and hit F to start, you'll notice that there's this tiny bar in front of everyone's turn order that kind of flashes a little. That is what is happening, and that's that UI turn charge or display turn charge that I was talking about. Next turn, this guy right here where I have my mouse, I don't know if you can see it, he's going to gain that much next turn. Okay. And so we need to separate those when we update the UI. And that is why we have this cache change in turn charges. So, okay. So we're getting the max of the turn charge cache. And if it's greater than 0, we are looping through all of these. Okay? And the reason why we check if it's greater than 0 is when we're done working with it, we're setting it to 0. And so what this is doing is it's taking the highest value first. That's why it's using max. And it's going to basically log that value and say, you're number 1. Okay, because this is how we're getting the turn order. You're number 1. And then it says, okay, now you're 0. You're first in line, you're 0. Okay, what's the next highest? Okay, you're number 2. Now your value is 0. And keep in mind, it's not setting their turn charge to 0 actually. This is the cache so that we can cycle through and go down, 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 down until we've gone through everyone and they're in order first to last. Sometimes simple things like setting the order of something, figuring out what the order of something is, there are many ways you can do it. And this can seem overly complicated, but it's not necessarily a simple answer when you have different actors and the different indexes of the arrays that you need to keep in order. Okay. So I'm going to leave this. Well, it's been up here for a while, so you can pause if you're trying to copy this down. But that's what this is doing, and that's the purpose of it. Okay. I'm going to scooch over so that you can see that in case you're trying to copy it. You'll see we've got the calculate new turn charge here. We've got the display new turn charge output that I mentioned was the UI element, and I pointed out a moment ago. And then after we've gone through all of them and nothing is greater than 0, so everything's set to 0, we're done. We've got our order of actors. We're clearing this, which is sorry. For some reason, the local variables thing over here disappeared. This UI turn order is it's a variable on the driver, so it's not a local variable. We're clearing that, and then we're adding them. We're getting each one of them, and then adding them in order, the actors, to the UI turn order array. So the UI turn order array is an array from 0 to whatever the number of actors in order that they are expected to act. And then we are updating the UI element, the turn order box UI element, providing all of these different values that we've collected in this function. Again, I'll talk more about HUD in another video. And then we're refreshing the UI. We're calling refresh UI again. Okay. Lastly, we are creating our status bars. So for each combat actor, we're adding a widget component to that combat actor, setting the space to screen. All of these are inbuilt functions. So I'll kind of pause for a moment so you can, or pause the video, whatever, so that you can see what's going on. We're setting the widget space to screen, setting the draw size to 200 by 400. That depends on your UI. This is the UI that I've created for it. This makes sense. We're setting the pivot. Again, you'll need to play with it if you have custom UI to make this look right for you. Then after we've added that component to each actor, we are then creating an HP bar widget. We're creating the widget. The component and the widget are separate, right? So we're creating the component on the actor, then we're creating the widget, and we're setting the widget on that component to this floating HP bar widget. We are then setting an HP bar tag on that widget. It's going to be important for later. but we're setting an HP bar tag on that widget. And that's mostly so we can find it later when we want to remove it. Okay. And then at the very end, we are refreshing UI. Then we finish up by calling the next turn event, which is going to consequently be the next video. So, hey, if you have questions, leave them in the comments. I hope you have a good day.